All right. Well, welcome everybody back to the Indicus Project. Tonight we are going to be finishing up the Lego Millennium Falcon. I'm really excited about that. Obviously, it's mostly done. All the lights are there. It seems to be doing everything, but there's a few odds and ends we got to cap out before we can consider this project done. So, a couple circuit things and a few timing things that we have to take care of. Also, we have another project lined up, submitted by a user or a viewer, and I'm going to be going through that. So hopefully we can get this project done with still some time left tonight, and we can start going into that. That'll be really important because that will be more along the lines of seeing the whole project from beginning to end, which is originally what I intended with this channel. But also that means a lot more work has to be done, and there's a lot of unknown because I've not done the whole process before. So we'll have to figure that out as well, what that's going to look like, me doing the entire design process from beginning to end, and how people will interact and help with that. But for tonight, we need to get one more software update in there. We need to get everything, we need to put a little bit more circuitry in to handle powering this thing just off of the brick here and not off of the USB cable. And then we need to get everything inside the Falcon and get it all put back together. And then we can consider it done. So I'm really excited. I hope you are too. And let's get started here. First things first. Whoops. Probably need to get rid of some of this. Let me just clean up my desktop. I apologize. I usually have this done beforehand, and I did not tonight. How's it going, Beth? I was updating my Twitch page because I decided not to stream on Sundays anymore, but I neglected to take that off the schedule, so I'm sure that was disappointing for some people. So I was taking that off. All right, there we go. That looks a little better. And I need to go in and open up everything to get us started. I think, yeah, we're going to need everything at some point, but we'll just start off with the lighting controller, or the lighting kit, actually. And when all this is done, too, I will commit all of this to GitHub, and that way you'll be able to see the files and use them if you decide to work off my work or if you want to contribute in some way. So that'll be cool. So let's get this opened up. Home from work, huh? It's always nice to come home and relax. Unless you're doing something like this and you got to immediately start working again. All right, and I think we need to update our current goal because we added the memory card commands last time. So that's in there, but we need to add a quick delay. All right, give me a sec. Add quick delay to lighting kit. All right, we'll say that's done, and then we'll get started here. Now, I said that we're going to finish this tonight. It's entirely possible that a lot of things go wrong and we don't, so I'm hoping to avoid that, but we'll see what happens. Here we go. So right now we have 3 major commands when we're in fast mode. Whoops. My computer's running a little slow today. Hopefully the stream quality's fine. If there's any issues with sound or the frame rate or something, let me know. But yeah, it looks like it's going pretty good. I'm a little worried because my computer and my network seems to be running a bit slow tonight. All right. So in fast mode, here we go. We have a few different commands. We have the U command, which is update, the exit command, which exits fast mode, and then if neither of those apply, then we drop down here and we do the just the update pixel command. And what we need to add into here is a single delay command that we can then add in if we're when we receive those commands and when we're running this thing automatically. So I guess we need to do another else if here. Else if. And then our fast buffer is the buffer that's receiving these commands. Yep, set to 0. So really, what I'm thinking is if the first character of that is a T, then we consider that a time command. So else if fast buffer 0 equals T, then this is where we handle the delay command in fast mode. I think we can basically do the same thing that we did down here, but it probably doesn't need to be nearly as complicated. Wow, yeah, that's actually really complicated. Okay. Well, let's just copy the whole thing and then cut out the stuff we don't need. Ooh, actually, I think I may have just realized a way this isn't going to work, which is really disappointing, but, well, maybe not. I think we can figure this out. Okay. So let's go here. So if fast buffer 0 equals T, and we're literally just going to do T new line, or no, T semicolon delay new line. All right, so temp buffer equals fast buffer. All right, so I need to go through and remember how exactly I did all of this. If you have any questions or anything, please feel free to ask. This is going to be a bit mind-numbing at first as I go through all this code and try to remember everything I did. We already know it's a T, so I think this doesn't actually matter. So we could probably take out all of this and just say point us into, yeah. And leave this as a empty loop. So what this will do is iterate through until it finds the semicolon. Oh, you know what? I probably can't do that actually. I just need to take out this line. That's more like it. Okay. Because these still have to increment. All right, so then we increment the raw command index. And then we validate that this is not the end. Otherwise, we just continue to the next loop. Next plus plus. String too long. This is not important because we don't need an index. So I think we can take that out too because the first item is a T character, not a number. Take this space out. All right. Equal, it does not equal that. Temp buffer. And then RGB, and then we should rename this variable delay. Nope. Time delay, so it doesn't echo that. And then we convert that number, and then we need to call a function, basically. Okay. And then this function just needs to be delay. I think I called delay here in this file at some other point. Yeah. Delay millis, okay. Let's take that. And then go back to where we were. Oops. And then we don't need index, we just need RGB. Okay, this in and by itself should work and should compile. So let's do that now just to verify that everything looks correct, that there's no errors. Also, the Falcon is running without even being run by the computer. It's just running off the memory card. Okay, time delay. RGB was not declared in the scope. That's because I used the wrong value there. All right, compile it again. Cool. I think it's looking good. Teensy loader. Everything looks good. I think those are just warnings about unused variables, which are fine. Initialize. Initialize in this function. Oh, there's more of them because I copied some code. Okay. So I should be able to upload this, and this thing should still run like normal. So let me do that real quick, and then hopefully... Oh, the teensy switch port's on me. That happens from time to time. All right, now let's upload. There we go. And then hopefully this thing starts over from the beginning. I don't know if it will, though. It may have read that... Oh, there it goes. Okay, good. So everything looks like it's still working, which is excellent. Now, in our main here, when we receive commands, but we're reading the file, or no, when we're reading from the serial port, we need to write these commands to the file. Serial.write. Something about this doesn't seem right. Like I'm missing something. Oh, here. This could be a problem. I knew it wasn't going to be easy. I was like, oh, we just got to do these few simple things. But there's something that always in the back of my mind, like, oh, it's not going to be that simple. And yeah, it's actually not that simple. When we go into fast mode, we receive the commands differently. File string compare. Fast mode for serial.write. Wait, no, where does this get set at? We have to receive. Get fast command. Here it is. And then down here we do the serial.read. Oh, that's disappointing. Okay. That means I think we have to refactor some code, and that's really annoying because that's going to take a little bit of time. I'm trying to think if there's an easy way to do it. Basically, up here in the main is where we're reading and writing to the file, and we need to get that file. We need to be able to do that in the command parts here the way it's working, or we have to change how the fast mode works, which is also an option, I guess. Since we didn't really realize that this was gonna be a thing, we didn't write our code with this in mind. So there's a couple options here. The fast mode is not super useful because now we're running the NeoPixels pretty fast and just reading from the SD card and everything. Like, it's not that big of a deal. So we may just... I'm trying to decide if it's worth just ignoring this, because maybe in playback mode you can only... Well, I guess if you were in fast mode anyway, it would never write to the commands on the SD card, so you would never get those to the SD card. So I guess maybe the SD card just can't use fast mode commands right now? Doesn't seem like a great solution. But it also doesn't seem like the end of the world. Does anyone have any thoughts? Do we just assume it's good enough for now, or do we try and do a bunch of things and possibly make a lot of mistakes to try and fix this? Ideally, we would do that, but for time's sake, I don't know if it's worth doing. All right. Well, in lieu of other direction, and since we don't seem to have any opinions on it, and I'm just trying to think through this, I don't know that it's worth it. We can do a quick test to see if fast mode is, if that works like I think it does. Where once we go into fast mode, it stops writing stuff to the SD card. We can test that real quick. And then, as long as that's true, I think we're okay to just move on and getting this circuit all kind of put together inside the Falcon. We probably need to figure out our final programming sequence too, like our final, whatever our light show is going to be. And then go from there. All right, so get this opened up. Sorry, PyCharm takes a little while to load. Well, in other news, how's everybody's Thursday or Tuesday night? I guess I almost said Thursday night. How's everybody's Tuesday night going? Any funny stories from the weekend? Plans? Okay. Check through this file real quick. It's going to run a little slow initially because... Alright, there's the only places we see that. In this Falcon class, I'm going to put some functions for a function for enabling fast mode. That way we can test it in the main. Yeah, the weather is finally getting better. I am glad about that. Oops. Gotta get my comments back right. All right, cool. This looks good. Okay, what's an obvious one? I guess restarting engines, right? So here, what we should do, mf.enable fast mode true, mf.enable fast mode false. Alright, so what should happen is we should run through this whole sequence, and doing the restart engines, we should run through that as well. And then afterwards, when we kill it and run it and just run it again from the beginning, you know, unplug the TNC, plug it back in, it should run all this stuff again, but not the restart engines, because once we're in fast mode, it should stop writing to the SD card. That is the theory. I don't know if it's going to work. Alright, I'm going to take out this while true. Actually, I'll just comment it out. I don't think that's necessary anymore. And we'll just move this back over. Alright. So, let's give it a shot. Please work. Alright, so starting over. Hopefully it's doing something. Let me go to the main webcam here so you all can see. And then, I don't think it's doing anything. We might be stuck. Oh, wait. It took a while to start there. I wonder what that was about. It like glitched out for a second. What did we miss? Okay, so those lights are going out like normal. I wonder if everything's running like way slower than normal, because it feels like it's doing that. Yeah, I'm wondering if there's like a delay somewhere that I forgot about. But right now it seems to be working. Alright, so that part right there that you just saw was it should not run back when we do it again. We gotta wait for lasers. And then landing lights come back on. And then because I took out the infinite loop, we should see this program. I'll see this program end and know when it's over. No ops. No, I don't remember putting any no ops in. Alright, engines were shut down. 5-second delay. Any second now. Oh, weird. It seems to be doing it again. Okay, I think it might actually be running from the SD card and that my Python program just isn't doing anything. Hold on. Oh, you know what? I think I know exactly what it is. I think I have to unplug this and plug it back in, because it's not... Once it realizes that there's no, like, serial communication going on, it stops checking for that and then just continues on. But there's like a 5-second period when you can start it up. So do that, and then start this. There we go. Yep, okay. So let me show you here real quick. You can see it's running. Those are the commands that are being sent right here. So now we're looking good. It's really cool to see the commands scrolling on the screen here, and it's auto, and it's due to some of the work we did before, it's auto-generating all the color values as it does gradients and things like that with the libraries, so that's really cool to see. There's a way I can optimize this library, though, to make this run a little faster, but I might do that later. Okay. Lasers. And then landing. So we should see the landing lights come on, and then the engines turn off. There they go. Here come the landing lights. And then we should see the engines turn off. There they go. And then my program should stop, theoretically. Okay, it's done. So now I'll unplug this. And the working theory is, because we had a... Here, let me zoom in a little bit. So right here for restarting the engines, before that we did fast mode equals true, and then after that we did fast mode equals false. And while we're in fast mode, we don't save the playback. So now I'm going to plug this in without running anything through the Python script. And we should see all of that stuff happen that we just did, except for the restart engines. The yellow flash as it lights back up. In fact, what we'll see is the engines stay off, and then it just does the firing the lasers. And then suddenly the engines will just come on right before the landing sequence. It'll be a little jarring, but let's give it a shot. It waits 5 seconds for the serial communication to start, and if it doesn't detect it, then it goes. Okay, here it goes. Cool. So it's already running. I have not pushed play on PyCharm. It's the Python script is not running, so this is doing it all on its own, with no help from the PC. Everything is off is from memory from the last playback. So landing lights go out. And then engine goes back down to cruising speed, I believe, so it should get a little bluer. There it goes. It's kind of hard to see. All right, now it dies. Now we shouldn't see the restart. But we should see the lasers. Maybe. Alright, well that's disappointing. It can't all work on the first try, I guess. There's a quick thing we can do to check this. We can read the file on the SD card. And that will tell us exactly what was recorded, because maybe something got recorded that I didn't realize and messed it all up. Alright, let me pull this up. And I'll flip over here. So these are the commands that were saved to the actual file. You can see it starts off with a delay. And really, we're not sending a delay over the Python script. These delays are generated in real time as it receives the commands. So it knows that, okay, I received, this command right here 3 milliseconds after this one, so let me insert a 3 millisecond delay in there. That way it plays everything back in real time without you having to send delay commands. I found that to make the timing easier to deal with and more accurate. And I just realized this is going to be really hard to look through, but we're basically looking for something that, alright, we want to see something that says like fast. I think I found it. Go up. Oh, there it is. It was just on the edge of the screen. Enter fast. So that right there was our breaking command. Because it entered fast mode, and then it didn't receive anything from the serial port, so it just stopped. So we need to fix that part. Basically, if the command is enter fast, we cannot write it to the... wow, that feels like that's a really long delay right there. If it's enter fast mode, we cannot add it to the SD card, to this script. Or this memory file. So, I don't really know another good way to do this other than, or at least quickly, other than just to check, does the command string equal enter fast? Okay. There's if running from serial, write command to file. So if running from serial, Oh, okay, then it just processes, but process command. I'm assuming that's the here. Yeah, that's the one that actually runs it. That's interesting. I didn't realize that I had set it up that way, but basically it processes the command and then writes it to the file. I guess that kind of makes sense. It validates it. So what we need to do here is check and string compare. And then, do we have these commands defined anywhere? I don't think we do. I think we only define them in that one place. We probably should do that, but for now, enter fast. And we'll compare this buffer. All right. 0 does not equal that. Okay. And then that needs to go in parentheses to keep everything straight. All right. So if the command is enter fast, then we should not see it, then it should not be written to the SD card here. Let's just verify that this works, that I've included all of my headers correctly. Looks good. Man, I love it. Terrence, I hope you're still on here. Your suggestion just to get the new hardware and just do it that way has been a lifesaver here. Because compared to the old chip of only having 2 kilobytes of RAM, and this one having like a whole megabyte, or I guess it says a half megabyte roughly here, has been hugely helpful. Because it makes debugging way easier. And I don't have to be careful anymore about my resources, because I'm running at 600 megahertz and have plenty of RAM and all that. So $30 saved a lot of headache. MVP award for that one. All right, let's load this. No TC ports found. I guess I got to plug it in for it to load. All right, and then what we're going to do is we're going to just eject this file or this card and plug it back in, and we're going to run the whole thing again, program it all again. All right, let's get the SD card in here. Okay, now we know that's programmed. Let's go back to PyCharm. Everything's plugged in, supposedly running. Let's fire it up. Oh, you know what? I waited too long because it's got to be plugged in and then started almost immediately. There it goes. All right, I know you all aren't that interested in the code, so I'll pull this up so you can see the actual thing running. Cool. I'm noticing that the way my library works here, if I go through and, well, let's see. Yeah, I need to add another layer or something to optimize that. Basically, if it goes through and has to set a bunch of these LEDs, it just goes through and sets them all individually. And really needs to realize that, hey, I'm asking it to set a bunch of stuff in a row. It needs to combine that all to one command. If it's in slow mode, at least. Okay, there's the lasers. Then we should see landing. There's the landing lights. And engine's off. Okay. And script should end. There it goes. So unplug that because PyCharm is done. And then I plug this back in and it should play it all back. All right, wait 5 seconds. There we go. I saw the flicker and the engine start up. Thank you, Beth. Yeah, it looks pretty cool. It still looks way better on camera than it does like in person, just because you can see the lights better in person. But and the camera just kind of blurs everything in a really good way. But we'll see. All right, so it flickers out, and then it shouldn't do the hot start. Nope. All right, that's disappointing. All right, what did we miss? This is the best part of any of these projects is all the trial and error to get these last little like bugs out. Like 99% of a software will work perfectly. Well, 90%. It depends on what you're doing. But, typically for me, 90% of the software will work perfectly the first time, but that other 10% just takes forever to debug out. Okay. It looks like it took it out. I don't see enter fast mode anywhere in this file. Let's see. I'm not really going to know. Because it's such a long file where the thing is that I need. But I'm wondering if a delay got like, if there was like a super long delay or something. What does it do there? It restarts the engines, right? So that's, yeah, it's going to be one of these things. 0, red, green, blue, green. This is the hot start right here, I believe. Unless it's the dying engine. Oh yeah, this is it dying. Okay. Here we go. Here it is. Okay, so it's still in here. Enter fast. Wonder why I couldn't find it on the when I searched. Interesting. All right, what did we miss? If running or serial and enter fast command buffer. What is command buffer? Is that just let's see here. Current command type. So command buffer should be the raw thing. Did I mistype something? Enter fast. I did. That's not a capital F. I think that's what was happening there. It's crazy how those little typos will get you. Okay, that looks good. Just plug this in and reload it, try again. The only annoying part is going back and forth on the SD card. And I need to do that because I need to verify that it's still doing the same error every time. All right, that's loaded in. And then we need to close this out. Go. All right. I realized I didn't flip back to that screen, but basically the result was the reason for that error was of a lowercase f, lowercase letter that I didn't do correctly. All right, let's start this. Here we go. All right, engines are coming on. Should see the landing lights go out here soon. There they go. Fade out. And then engines go back down to blue. That's it. All right, now they die. Then once again, fast mode and restart. Man, fast mode feels like it's way faster. All right, and then we should see a landing. So we should see landing lights. Or no, lasers, right? Oh, I got stuck. That's weird. Something I did got it stuck. Let's try again. Nope. Won't work immediately. That was weird. I should probably just comment some things out and just run it through a couple of the sequences just to test this out. Yeah, I'll probably do that again next time. All right, running everything again, though. Because it got stuck somewhere. It didn't reach the lasers. All right, there it goes. And then enter fast mode, restart. Weird. All right, so what are we missing now? What did we change that affected that? All I changed was whether or not it was a lowercase or capital F. Huh. It's always the little things that get you. I'm guessing it didn't receive the command. Oh, yeah, it wouldn't. Okay. Here, let me pull this up so you can see what's going on. Oh, Streamlabs just is freaking out. Okay. So what I did here was I basically said if string equals enter fast, do not go into here. And one of the things it does is respond with the command received response. Right. So that's not going to work. I guess I got to break this up into two different if statements. Because it wasn't responding that it had received the command. But we do know that that means that it did the string compare correctly, so that's at least a bonus. So up here, let's do the right. And down here, we'll do the response, and we'll take out this second condition. There's probably an easier way. You could probably nest these a little better, but visually, I just like the way this looks. And let's just add some comments in here so we know what we're doing. Written to the file. Check if we should respond. Okay. We are, oh man, we're so close. Error compiling. That was weird. I think I've got that error sometimes if it's in the middle of saving something. All right, let's upload this. All right, and then for the sake of quickness, we're going to take out some of this. Actually, should probably be this, right? Yeah. We're going to just do losing power, restart engines, and fire everything. And we'll take out these commented out sections in a second. But this way we can run our simulation a little faster. All right, let's plug this in. Oh, we're still running from last time. All right, engines die. Then they should do the restart. There they go. And then fire lasers. Didn't work again. Man. All right. I appreciate all of you that are sticking with me right now. This is just one of those annoying problems. Where do we print this out at? Is it in here? Yeah, here it is. Print command equals command received. Weird. This isn't working like I think it is. Salts. Send slow command. Is there a send? There should be a send fast command, right? There is not. Interesting. All right. Well, I'll run this again, and I'll show you all what's going on here so you can see. Oh, it stopped for some reason. All right, let's try this again. Exit. It still doesn't receive the command receive. But, well, not that it doesn't. It just doesn't process it. Oh, what am I missing? What am I missing? I mean, it's got to be something. So I'm not changing anything there. I'm just printing stuff out. It's got to be something here that I'm missing. Write command to file. If running for serial or spawn command received. Which it should be doing. Oh, TC did not respond. I wonder if it didn't program then. Okay, yeah, that's killed. Well, something showed up later. Is there just a really long delay in there? That's weird. Okay. It's running back what it thinks it was supposed to do. Okay. Weird. All right, well, let's kill this. And we're going to go here and just upload this again and see if we have the same issue show up. Okay. So supposedly that's uploaded. Now we'll unplug and try again. just to make sure that I'm not going crazy here. All right, there it is. So, oh, okay. Maybe that did fix the problem. All right. So that works supposedly. So now I'm going to pull this up, and we should be able to run it back and not see that engine restart. So it'll wait 5 seconds. Engine dies. And then lasers? Any second now. Hey! Okay, I think, yeah, then it starts over. Okay, cool. Finally, that was a bit of a nightmare. I'm not totally sure what happened. Something didn't get loaded onto the Teensy right, and that's what caused an issue. Oh, excuse me. So, always double check the little things. I'm going to take out some of these lines of code because I don't think we need to do this anymore. Just the stuff here that I was printing out all of the items. And we'll go back to main. And we need to basically decide what we're going to do as far as like what our profile is, because I want to just go ahead and run that and save it before I start messing with things. So right now, let's see. So we start off with engine kill. We start up the engines. We lose power. Or no, we start up the engines, take off, lose power, restart the engines. We can take out this section now. We don't need this anymore. Fire the lasers. Land. And I guess we need to do a takeoff again. Because I want to do the hyperspace thing as well. So wait like 2 seconds. And then taking off. Which I think was the one we used up here. Yep. Oh, we probably need to start up engines before that as well. Engines. Sleep 2. And then go to hyperspace. And then we should be good, right? So that's a whole sequence, more than what we're doing right now. All right, let's run it back. And let me, yeah, I guess I'll update the goal in a second. But let's start from the beginning. See what we can do. Okay, it is working. I didn't think it was working, but I forgot I took out all the print statements. So it's like, why isn't it doing anything? All right. Let me know what you think, if there's something else we should add to the lighting profile or, you know, whatnot. It's looking good so far. I'm going to make a bad assumption that this is going to work and go ahead and get set up for the next part. Looks like it landed. Now we should see engines die down. Yep, there they go. And then start up the engines. There they go. We should see it take off and go to hyperspace. All right, landing lights go out for takeoff. And go to hyperspace, please. Give it a sec. There it goes. It get really bright. And then just die. Whoosh out of existence. Yep, there it goes. Cool. All right, let's unplug that. And then plug it back in and we should see the whole sequence play back. Oops. There it goes. All right. Sweet. Everything's looking good so far. I don't know how long I can go to, but this is a 128 gig SD card, and there doesn't seem to be a limit. I mean, it's really just however long the file is. Theoretically, I could run this thing for maybe a few hours doing some light display. It would have enough memory to do it. I just don't know if the protocol, the stack protocol that opens up and mounts the SD card and reads the files, if that has a max file size. It might. It just depends on how it's designed. It might not. So that'd be kind of cool though if I could do like a 10-hour display with no like repeating pattern or something. All right, let's see hyperspace. Any second now. There it goes. Man, it takes forever to get up to that full brightness. All right, and it starts over. So we're looking good. Sweet. All right, let me push some of this stuff out of the way. We're going to need a little bit of space here to do this next part. All right. This, and I think I need to unplug this too. All right, what's the best way to do this? There's the ground. I'm basically going to have to add an input line on this. So in order to run this completely apart from the computer, I need to make sure that I don't need to power the Teensy from the USB cable. And the way I do that, there is a pin on here that leads right in on the same input line that the power from the USB would. And basically you can give it anywhere from, according to this, 3.6 to 5.5 volts. And this is a 5-volt controller. So I just powered off that, but I need to solder a wire to it. I figure orange is probably a good color for 5 volts, right? Is that what we're using here? Yep. And I got this new nifty little stand to solder things with. Hopefully make things a little easier. Where's my little board? There it is. Fire this up. And get some solder. All right, let's turn this up a little bit. And as usual, hopefully I don't burn myself. We'll see what happens. It's only 750 degrees. There we go. Okay, that's in, but it doesn't look like it has very much solder on it all the way through, so I'm gonna put some more. There we go. I'll stand this back up a little bit. Okay. Gotta be careful not to have lines cross here because I have a couple different voltages going around and lots of different data lines and stuff, so I don't want to short anything. All right, that looks good. That back out of the way. And let's get this thing wired back up and make sure it works. What is there? Yellow is low voltage. Orange is high voltage. High being 5 volts, it's not that high. White being data. Okay. I plug this in here, probably doesn't explode. We'll see what happens. I guess there were probably smarter ways to do that too. Oh. Hey, it's working. Check it out. I don't even have the USB cable plugged in. It's running off memory right now. It's literally no connection to the computer. We can move this out of the way. It's all running off of this power line just to power it. It is possible to run NeoPixels off batteries. Depending on the brightness and everything you do, it will last so long. I have a feeling that with what I'm doing and how bright some points are, the batteries would die fairly fast. They wouldn't last very long, maybe a few hours. So it's just easier to have the power cord. Plus, once you include batteries, you need a way to switch it on and off. Thanks, book. I think it looks great too. Okay. I guess the next step, what are we doing? How are we doing on time? We're just a little over an hour, so we're doing good so far. All right, we should see let's wait for it to finish out the sequence. Should see it take off again. And then we should be able to see it go to hyperspace. So I don't need that anymore. What we'll have to do next is shove a bunch of stuff like these wiring down in there and then put the covers back on and then test it one more time and just make sure it all it works. and then we'll be done with this project, which is awesome. Okay, looks good. I guess we have to put it back together. I'm going to have to stand up for this and lean over. I apologize. My voice is going to go a little quiet because I'm away from the mic. Maybe I can move it out here some. Thanks, Terrence. All right. For the most part, uh-oh. Get a weird blinking red light, which I don't like. Like when I moved it, something happened that it didn't like. Okay, it's still running. Oh no, I broke the I broke the radar. How symbolic. Oh yeah, there must be a loose connection here. Because when I move this thing around, it there's a red LED that comes on and it starts freaking out. All right, let's unplug it for now then. Best not to have power running through this thing when I could possibly short some wires. All right, I'll get that breadboard down in there. Drop the teensy down below so it's locked underneath everything. And then I want to move this piece up so that this little retention piece is in here. Effectively, I'm kind of making a bit of a strain relief piece here. All right, there we go. And then I'll have to double check this bottom panel later to make sure nothing is weird there. Okay, that looks good. Now, tricky part. Oh no! Dropped one. Okay, now you just gotta get this piece back on. All right, and then this piece here. We got little zip ties in there. That's not going down all the way. I think that wire's pushing up a bit. I might have to go mess with that later. Well, actually, it looks about the same as the other side. Okay, that looks fine. I think it looks good from your all's angle, too. Hopefully I didn't knock anything loose. Let's plug it in and try it. Please work. I don't want to take it apart again. All right, come on. 5 seconds. Oh. Hey. There it goes. All right. I think we're there. Let's just make sure it keeps going. There we go, the engines die. Hot fire comes back on. Should see some lasers. There they are. Should see it land, so landing lights underneath. There they go. Engines turn off. There it goes. And Then the engines come back on because we got to do takeoff and then go to hyperspace. All right, I think we're looking pretty good. Man, I've been invested in this project for like 2 months now. Between building the whole Lego set and putting all this in. All right, let's just see it go to hyperspace. Should get really bright here. There it goes. And then just die. There we go. And then it'll start over. And anytime I want to program it, I just plug that USB cable into the teensy and run a different script, and it will record whatever happens, and then I can play it back. Oh my goodness. Such a long 2 months. I appreciate those of you that are here with me right now watching, because this has been such a long time coming. Monster Jam, thank you. For anybody that's just tuning in this time too, like all the reason this was so difficult, it required thousands of lines of code and everything, because all of these lights inside here are individually controllable. I can make them any color, any pattern that I want to, any brightness, just like a pixel on a computer. And I can flash them, you know, several, even a few hundred times a second if I want to, provided I do it the right way. So it has potential. And not only that, we've designed a very good system that we can use to light up other stuff. So I was talking about lighting up a desk or backlighting a TV and a bunch of bookshelves and things like that. I could use the same system to do something like that. I'm glad it's been fun to watch. All right, so let's drop back here to our coding screen. Don't worry about this. I just wanted to update the current goal here. And we'll just say celebrate, because it's finally done. I get to have these once in a while. Okay. So, that's been awesome. I got to figure, so we got to move on. I hate to just immediately jump into the next thing. But I was hoping to finish a little early tonight, which I did. I still have about 45 minutes left. Can we see it one more time with less room lights? Oh, that is such a good idea, Beth. I'm really glad you mentioned that. Give me just a sec, and I'm going to go through and turn off some of the lights here in this room, and we'll see what it looks like in the dark. This will be a little better. I didn't kill I just turned down the one lamp to its lowest setting, and then killed all the other lights. Yeah, it should look a little better. There's not really a good angle to see everything from, because there's the lasers happening on the front, the engine in the back, the underglow is all around underneath. Kind of the best on that side, though. At some point in the future, I may go through again and like hot glue a bunch of stuff into place so that it looks a little better. Good. I'm glad it's perfect. All right, lasers. Oh, it looks like I had a little hiccup there. The teensy might have timing problems occasionally if it's got an interrupt that fires at the wrong time. Something else to note, I did find online on Amazon, there was a lighting kit that you could buy for this. I think it was like 90 bucks. And I made this, I guess if you go all said and done, probably $70 worth of parts to make my own. So you figure I saved 20 bucks, but I also spent like 20 of my own hours, you know, wiring this up, soldering, writing code, testing, debugging, and all that stuff. So in the end of the day, I probably didn't technically save money because I spent a lot more of my own time to do it. But I did do it cheaper technically. So small victories. Is it going to hyperspace now? Yep, there it goes. I think it's really bright. Jeez. Right at the peak there, every one of those LEDs in the engine is pulling like 60 milliamps, and there's 10 of them. So we're pulling zero point 0.6 amps just from the engine alone when we get to the edge, well, right before hyperspace, or right at the end of hyperspace. Thanks, Beth. Yeah, it was a long one. All right. So as far as what's next, thanks, Monster Jam. I think so. I got a submission from another user, and I'll turn the lights on in a second. I got to decide exactly how I want to do this, but as mentioned before, you know, below in the about page, there's a section for requests, and if you have an idea for an engineering project that you want done, you can submit it there, and you can put in requirements and things. You know, just the best of your ability. It doesn't have to be. It's not an exact science, and any and all is welcome. You remember back to chapter 1? Yeah, starting off building this thing, just the building the frame out of Legos. Yeah, that was 2 months ago, man. Um, so I got a request from another Twitch streamer who wanted me to make a MIDI controller, you know, with the volume sliders and a few buttons for like play, stop, pause, because he makes music and he wants something like that to easily control some volume and just to start things and stop things. And a lot of stuff actually that does that is fairly expensive. And I was looking around online, and I figure I could get the parts probably for about probably the higher end because I'm only buying really one of each, you know, 50 to 70 bucks or so. But I could have basically a homemade designed one, and so I think that's what I'm gonna do. He submitted a project request for that, and I need to figure out basically what that design process is gonna look like because I want you all as the viewers to be able to participate and, you know, give feedback and ideas for things you want to see done within the projects. And I need to also illustrate the entire process, and we really need to come up with kind of a formal design process. This was already kind of in the works as my idea, which is why we never had like a formal design because I already kind of knew what I wanted to do. But with this new project with the MIDI controller, I'm going to have to design it from scratch, and I'm going to need your all's help to kind of give me ideas for how to set things up and just everything that goes into that. It'll mean getting another, we'll probably use a Teensy, much like the one that we used to power this thing, but we'll use a smaller one called we used a Teensy 4.1 here. We'll just use a Teensy 4. It's everything the same, but without the SD card. So it's a little smaller, and we don't need the SD card for a MIDI controller. I think also with the way this is going, we're going to have to build an entirely encased black box solution. I'm thinking we're going to design our own PCB, our own circuit board, which, if you've never seen that done before, is actually not nearly as difficult as it sounds. It's just a matter of getting the software and literally designing it, drawing it out, drawing the wires and everything. So it's not too bad, and I'm hoping it'll be cool for people to, you know, who've never seen that done before, just see what that process looks like. I've done it a few times just through various jobs and things like that. And so yeah, but we need to start off and we need to formalize a development process, like how we brainstorm, how we create a prototype, how we expand on that, you know, those sort of things. So I'm going to have to give some thought to that. I think right now what I might do, let's see, I'm going to close out my existing IDEs right now. I don't need them for the moment. Also worth noting that I'm going to post all this stuff to GitHub. If you check the About section below, you can find a link to the GitHub, and there you will find all of the project files for this stuff. And that way you can tinker with the code yourself or build one yourself. You know, if you have any questions, email me. I'm happy to I consider these designs all sort of a public domain or an open source of type. So I'm happy to answer questions and tell you my rationale, exactly how I did it and what I was planning on doing and those kind of things, so you can get an idea of how exactly it works. All right. I think what I'm going to do is pull up, let's create a new note, new text document. I was talking to my wife about this earlier, and honestly, I need a way to like draw things on screen, and I was trying to figure out how exactly to do that with Windows and with no way to actually sketch something. I don't have like a tablet or something that I can like sync up. That'd be really cool if I could do that. But just so I could draw like block diagrams and then basic product ideas so that you all could see exactly what I was looking at. All right, what I'm going to do here is go to this email I got for this project request. When you submit a project request in the About section, it just sends me an email. And let's just write this out. Oh, caps lock on. Here, let's make this a little bigger. And then, oh, sorry. Let me pull this up so you can actually see it. I figure I'll put these requirements on screen, and then if anyone has any thoughts or ideas on how exactly this should be done, this design process, I would love to hear them. All right. I would like a MIDI controller. I'm literally typing this out verbatim. I should just copy and paste it, but I don't want to risk pulling my email up or trying to log into it on stream right now. So need to control parameters. Then Digital Audio Workstation. I've never heard that acronym before. Shows you how much I actually do with like streaming and stuff. Okay, and then we have a lot of requirements. The streamer who's doing this, his name, here, I'm going to put his name up here. Bitamy. I've got his channel as one of my recommended channels below. He does some really cool stuff with music and video game music. It's worth checking out. He does this really cool series on YouTube where he takes other artists' work, other drawings that people have made, where they draw characters and things like that, and he writes a soundtrack for it. So he's come up with some pretty cool stuff, and he streams occasionally, so you can like see exactly what he's doing and how he writes music. If you're ever interested in any of that kind of stuff, it's worth looking into. All right, requirements. Must work on Mac OS. I can already see that this is going to be the hardest part. On Logic Pro X, which is his software that he uses to write music. Basically, the reason why this isn't the end of the world is that there's a standardized like communication across USB for this kind of thing. So as long as you follow that standard protocol, it typically works on just about any platform that supports that protocol, which Mac OS and Windows, most programs within those operating systems do. So that's why I think we'll be able to pull this off. Must be able to control. This is what I get for just typing this verbatim. Must be able to customize. Let the sliders control within the workspace. This was an interesting one because he mentioned it, and I suggested he add this. The wording used, weighty enough to not slide around on the desk. So basically, when you slide the switches, the controller itself must not slide around. It's not going to be very big based on the requirements he's given me here. So it's kind of important that we get that part down. So it either needs to be weighty or what he suggested here, rubber grips on the bottom. So we could put little rubber pads underneath, and then that would keep it from sliding around a little bit too. We may do a combination of both. We should try and put the heaviest weight we can in it, so it's a really heavy little mini controller. All right, the slides should be 3 inches. He specified that, okay, the way this is worded, USB-C A+, so I'm assuming that's an optional, but we would prefer that. Yeah, so I'm just going to say USB-C preferred. That's not that hard to do either. We can just use a cable. 3 sliders. And then he specifies what these sliders should be. So this, what I was talking about earlier, depleted uranium heatsink. I love that idea. Where do you think we could get that cheap? It'd be like a 20-pound little box. It ain't sliding around the desk. All right. He says, so I'm assuming these are, he mentions some different channels here. CC11, CC1. So I'm assuming these are the 3 slider channels. And this is what the protocol I was talking about earlier. Basically, there's a standardized protocol on these controllers, just from research I was doing, where you just tell the computer that, hey, this channel has changed. Here's the type of change, and here's how much it's changed. Something like that. And then the computer software itself maps out, okay, I know what channel goes to what things. So I just basically set up these 3 sliders to do these channels. And then when this guy sets it up with his software, he will basically select, I want this channel to control this volume, and this channel to control this volume, and this channel to control the tone of this. And then when he changes those sliders, it will tell the computer that these channels are updating, and then his software will decide what that actually means. So that makes it easy for us. And yeah, so all we're going to be sending is values of here's how high the slider is. All right, and then he wanted 4 buttons. A play button, a record button, a stop button. I'm assuming we'll just set up random channels for these as well, but we may want to color them. So the play is green, stop or record is red, stop is white. And then he wants a tempo / miscellaneous. Maybe we can make that blue. Oh man, we could use light up buttons for this. That would be really cool. Light up push buttons. Push button switches. All right, and that was the entire thing. He also gave a suggestion for an enclosure here. So I'm going to pull something up. And we're just going to look around, and I'm going to show kind of my rationale for this as soon as my internet loads. Hopefully this doesn't kill my stream. I have issues if I'm doing both directions at the same time, downloading and uploading. Here we go. All right. So this is a cool website. DigiKey. And then what we need here, now that I'm done typing that, I'm going to pull my chat back up. All right, so what we need here, I'll show you kind of what I'm going after. So as far as the controller board, if I can get this to load, man, the internet's going slow tonight. We're going to get one of these, a TNC4. This is the same board that I have, same processor that's in this Falcon right now. But it's a little bit, it's actually about half the size. So That will be excellent. And that's a 3.2, but here's a teensy 4. And it's only like 2/3 of the cost. It's like $20 instead of 30. So that's also a bonus. I think we can get them off Amazon, which will make this a little easier. All right, and then for the volume knobs, we're going to use a slide potentiometer. $828 items. Well, they have a lot of options for us. That's what these things are. So all this is a variable resistor that with a slide knob on it, and as you slide up, the resistance goes up, and as you slide down, the resistance goes down. There's actually quite a few here I noticed, which are illuminated. So let's see here, just real quick. Active in stock. Oh wow, only 71 out of the 868 left when we do that. Okay. Yeah, a lot of them have LEDs in them. And I think we could use that. Ooh, this looks like a good one. A little expensive, but it looks really nice and solid. So I'm thinking we use one of these illuminated one, because then the knobs can be light up. And I think that would just be really cool. So right now what we're doing really is just brainstorming. So if you have ideas of things that you think we should do this, or questions, now's a great time to ask. Maybe next time, I'm trying to think how I can sketch things out, because I want to draw like diagrams and stuff. I'll figure that out, but all right. Yeah, this looks awesome. What color is it? Doesn't say. We can go look at their data sheet real quick though. Internet, as always, takes forever. I don't know why it's been so slow here lately. They have red, orange, green, amber, and white. I know it's kind of hard to see. But right here, they have their colors. So those are the different LED colors we can get them in. Length of travel, 20 millimeters. Oh, that could be a problem. That looks so much bigger in the picture, though. He specified that he wanted it to be a 3-inch travel. So that's like 75 millimeters, 76 millimeters. So we're going to have to find something a little bit longer. Okay. Well, that's good to know. That we may not be able to possibly use these. Travel range. Well, 60 or 100. I guess I'll have to pick. Let's check out both of these. Categories. Let's just see. Oh, wow. Yeah, some of them are still pretty cheap. Some are pretty expensive. So what we can do with what these things essentially do, if I understood some of what I was reading earlier, is they effectively form their own voltage divider. And so as you adjust the switch, the output voltage changes. And then on the teensy, there's a thing called an ADC, an analog to digital converter. And that just reads the voltage, and whenever it changes, it assigns a number value to the voltage. So anytime that changes, we'll get a different number value, and then we can send that back. Since this has the whole divider built into it, usually, it's actually a pretty easy circuit. You just put 3 volts on one end, ground on the other, and in the middle you just get your output. Yeah, it looks like these illuminated, they don't have illuminated ones that are longer. This one has a motor in it. That's wild. So standard LED. How many does that give us? Probably just like the one, right? Okay, yeah. So it looks like we have to do a 60 millimeter one if we want the LED. I'll have to ask him about that. Also, these are kind of expensive. Well, some of them are. What's the difference? Red, orange, white, green. I'm assuming that's what the difference is the colors. We could see that here in the data sheet by the part number. Somewhere in here is going to be a part number definition. We can go off that. If anyone sees it, let me know. Pots can be noisy too. Yeah, you're absolutely right there. They can be. The reason I was so willing to use these is because the actual like physical application of this, the intended application, is this exact thing. Yeah, here we go. Applications, mixing machines, drum machines, keyboards, equalizers. So basically exactly what we're doing, music equipment. That's why I was so willing to, even though, yeah, you're right, potentiometers can be noisy, this seemed to be a good option. We could probably set up some circuit to make that, to lower that noise with a capacitor or something. All right, I'm looking for my part numbering scheme. Geometer, hole detail, product dimensions. Oh, there's two different options here. They do have a 100 millimeter one. Yeah, you need to filter the output. Yeah, you're absolutely right. Oh, here it is. All right. Part numbering scheme, this letter was the one that kept changing, and we see that, in fact, that is the color. Looks like amber was not on it. So DigiKey has red, orange, green, and white. Oh, that's cool. There's actually a lot of different travel links here, and this digit is the travel link. So if we go back here, 0160, 0160. What's 01? 100. Okay. So if you want a 100 millimeter one, then it's $5.60, or it's like half that if you want a 60 millimeter one. I'll have to ask him, because neither of those are the 3 inches he requested. But that doesn't seem to be one. 3 inches doesn't actually seem to be a standard length. So I'll have to see about that. Another thing to note with the, let's see, what colors are available in the 100? Red and white. Or if you want orange or green, you can get the shorter ones. We can always go to another site too. This is just an example. The other thing to note about this stuff is that quantity matters. And it looks like it won't matter for us. But basically, the more you buy, the less they charge you per unit. So if you buy 5,000, it only costs half of what it is per unit if you buy one. In some cases on this site, this has led me to, especially with like resistors and things, I would buy like 100 resistors versus 10 because actually buying 100 resistors is cheaper than buying 10 overall. Not just a cheaper unit price, but cheaper overall. Just the way the math works out. So sometimes you go up because you're spending like 2 more pennies for twice as much product or something. That's a wild world buying electronic components. All right, so that looks like a good option for there. And then we also need push button switches. $175,000 choices. Well, we should be able to find something we want in here. In stock, 6,100 of those 175,000 options. I think we decided we wanted illuminated. And there's a lot of different types. Oh, wow. Let's just click on all the illuminated ones to start with. All right, that's half of them. Yep. I want something through hole. I don't want to do surface mount stuff with this PCB just because it'd be easier for me to solder. don't want anything open topped like that. If there's anything we could get like, well, here, let's do through hole. Start with that. That'll get us closer. And then I want something pretty flush. Let's do key switch. Interesting. Those are interesting. Not quite what I had in mind. I'll have to look through this some more and search around some more. There's a term I'm missing because what I'm thinking of in my head, I've seen something cool before that can do it. Let's see. Let's take out the type. Is that illuminated? Odd if it is. I don't want anything with this like open top. I know that's so you can put like your own type of button on it, but I don't want to have to do that. I just want a more standard solution. That's not bad. All right, we'll get into that a little more too. So as far as our process goes, I would like to draw up some block diagrams, at least of the circuit initially, and then well, I guess in one of the entire enclosure too, just to get an idea. And then from there, actually design a circuit. And then, or okay, I guess I should back up. From those block diagrams, we can figure out if there's parts that we can do initially and then add on later. More of an iterative style process than a do everything at once waterfall style. Because that's what I really want, is something iterative. But once we make those block diagrams, we can get an idea. Then we could get the parts and build the circuit just with breadboards and things, and validate that it works, that the circuit looks good. And then we can start developing code for that circuit. And then we can design a PCB and pick out enclosures and all of that stuff, and design a final form solution. So that involves, circuit design. It involves software design. It involves PCB design, and then some final CAD design of the whole thing. So we're going to be looking at going through a lot of steps here, and I need to really formalize that process and possibly figure out a way for people to be able to help, so that it's not just me doing this. All right. That gives us an idea. If anyone else has any thoughts or things about like, hey, I think this makes sense to do it this way or whatnot, let me know. Or just any concerns you have or questions you have about what I'm trying to do here, let me know. And I will answer as best I can, or hopefully that'll get me thinking about something that I didn't realize. And then I think for next time, I'm not sure. I need to figure out a way to sketch stuff on screen so I can draw up a block diagram. Maybe I can just use a diagram editor or something. Just use Google Sheets or Google Drawings or something. I really don't want to. I wish I could draw by hand because I could just do it faster. But yeah, we'll figure that out. And then from there, we'll work our way through it, and we'll kind of design it. I came up with basically a rudimentary design process there. We'll see if that works. We'll have to tweak it as we go. Is there anything else? Pull this up. If I can't get ready to do that by Thursday, I might just build another Lego set on Thursday, just to fill the time. I have one other one sitting here that I need to build. It's not that big. It's just a cool little Clone Trooper 501st group, so from the Clone Wars. So that might be worth doing. Yeah, maybe I'll do that Thursday, and then I can have the weekend to kind of plan everything out for this next step. But yeah, you have questions, check out the links below for Twitter and Instagram and everything, and follow me, and send me questions on Twitter because I'll try and respond as fast as possible. So, all right. Well, thank you everybody for joining me tonight. I really appreciate those of you that stuck around. This has been such a I can't get away from the fact that this Falcon has been here for forever. It's going to be kind of sad to see it go, see it leave the table so that we can work on something else. But it may make an appearance in the future. I have some ideas for how to improve it, but I just didn't want to do that now. I was ready to move on to another project, and it didn't seem much reason to do that right now. So, all right. Everybody have a good Tuesday. I thank you all for sticking around and for helping me out with this. And I will see you all Thursday. Have a good night.